All right, we're at 2:02, so let's go ahead and get started. I'll start off by introducing myself. My name is Anna Weitz. I'm an engineer with the Southeast Onsite Energy Technical Assistance Partnership. We are based out of the North Carolina Clean Energy Technology Center at NC State University. This is the first in our webinar series called Deploying Onsite Energy, and today this one is called Decarbonization Begins Onsite. And today we hope to introduce the TAPs to you, discuss on-site energy technologies and their benefits, and let you know how the TAPs can help you. I'd like to go over some housekeeping items first. All participants are in listen-only mode, so you won't be able to come off mute or see yourself on the screen. You'll be able to just see us. Please enter any of your questions into the Zoom Q&A feature. We'll have time to answer all your questions after the presentation. We are recording the webinar and it will be uploaded to the NC Clean Energy Technology Center's YouTube account, which I believe right now I should be able to post that to you in the chat. So I just put a link in the chat. I believe you should be able to see things that we chat to you, but I think the chat feature is disabled for participants. So you can go to our YouTube page to see the recording of this webinar afterwards. When you registered, you were given the option to sign up for continuing education credits. If you did so, we will cross-reference your complete attendance today with your registration and send you the appropriate certificates after today. You'll be able to receive a certificate after each webinar session, except for if you signed up for USGBC credits. For those, you'll have to attend all 3 webinars in order to get that certificate. And these are all the housekeeping items, and I'll keep my eye on the Q&A section to see if you have any technical issues or have a comment or a question that could be addressed or answered in the moment. But otherwise, our questions you can put in the Q&A section and we'll get to them after our presentation. All right, moving on to our content for today. We have 2 speakers presenting today. The first speaker will be Isaac Panzarella, who is the director of the Southeast Onsite Energy TAP. And the second speaker will be Art Sandberg, who is the assistant director of the Southeast Onsite Energy TAP. Isaac and Art are both veterans of this program, and they have been part of the evolution of the Onsite TAP program for over 10 years. And Isaac, go ahead and share your screen now. Thank you. First, I'll go over the agenda. If you advance to the next slide, please, Isaac. Thank you. All right, our agenda for today is first to introduce the on-site energy TAPs, then discuss the application of technologies for on-site energy, talk about portfolio and site screening for on-site energy, and then Art will cover the benefits of on-site energy, and Isaac will finish the presentation by talking about how the TAPs can assist you and make you aware of the implementation grant opportunity. At the very end, we'll have a Q&A to answer any of your questions, and you can put those questions not in the chat section, but in the Q&A section. And with that, I'll hand it over to Isaac to introduce the TAPs.
Thanks, Anna. So I'm Isaac Panzarella, like Anna said. I'm a mechanical engineer by background, and I've got over 20 years of experience in sustainable building design and construction, as well as renewable and clean energy deployment. And I'm very pleased to have you all here. Bienvenidos a nosotros, amigos, en Puerto Rico. So to start off, I'll talk about the TAPs, which are funded under the U.S. Department of Energy's Industrial Efficiency and Decarbonization Office's On-Site Energy Program. And the mission of the TAPs is to help industrial facilities and other large energy users to transition to clean energy, to lower their costs, reduce emissions, and contribute to a clean energy economy. And to fulfill this mission, the TAPs have 3 main services. One is providing technical assistance to end users. We'll talk a lot about that today. We also engage with end users, which include utilities, state regulators, and other officials. We'll cover those in our next webinar. And then end users, of course, which we're talking about here, is we engage with them through conferences, workshops. We're partnering with organizations throughout our region to help connect people in a network and inform them and support them on clean energy development. This map shows the national scope of the program. We're with 10 regional TAPs, and we're based at NC State University at the NC Clean Energy Technology Center and in Raleigh, and we serve the Southeast, and that covers Alabama, Florida, Georgia, Kentucky, Mississippi, North Carolina, South Carolina, Tennessee, Puerto Rico, and the Virgin Islands. And all the TAPs, we are a network that's connected together. We collaborate very well together. And like the other on-site energy TAP teams, ours is made up of professionals with experience in the analysis and development of on-site energy in our region. And also, that includes knowing the industries that can benefit from on-site energy, knowing the energy market and utilities, as well as applicable state and local policies throughout the region. So we have on our staff 4 engineers, an environmental scientist, a number of policy analysts, and faculty at a couple of universities. One is Dr. Pedro Quintero, who is the lead for our Puerto Rico activities, and then Dr. Ethan Languri, who supports us with engagement activities in Tennessee from Tennessee Tech University. So applying on-site energy technologies. On-site energy, the way we're talking about it, encompasses a broad range of technologies that are suitable to serve large energy loads. And that includes battery storage, combined heat and power, district energy, fuel cells, renewable, solar PV, solar thermal, and others. And I think the best way to talk about these technologies, many of you are probably familiar with them, is I'd like to talk about a few example projects where on-site energy technologies have been implemented. The first one is BMW manufacturing in South Carolina. BMW manufacturing employs 11,000 people at this site that assembles BMW X3 through X7 vehicles and some variants. And the site has an annual export value greater than $10 billion annually. On-site energy is a key sustainability strategy for BMW. And for this site, from 2006 to 2003, they reduced the energy consumption per vehicle by 67%. It's an impressive achievement that's been really achieved through the use of on-site energy as well as other things. Combined heat and power fueled by landfill gas is the primary on-site energy technology at this facility. This site, like many other industrial sites, has processes that require thermal energy, steam and hot water, and that can be costly to electrify. So what CHP does, it serves as a technology that produces electricity as well as that thermal energy. And to help them meet their sustainability goals, LFG, landfill gas, is a great solution. This has enabled them to reduce annual GHG emissions from the site by 92,000 metric tons of CO2 equivalents. It's a very large reduction through the use of renewable landfill gas. So great job there at the BMW site. They recently upgraded their CHP system in 2009 to generate 13 megawatts of power. And they also have a small solar array on the visitor center that powers our visitor centers. That's 96 kW. And another unique feature is a hydrogen fuel cell fleet that includes fork trucks and other um, uh, industrial equipment pieces, numbering over 800 at the site. Next is NC State University, with over 38,000 students and 10,000 faculty and staff across 2 campuses. NC State is comparable to a small city. It owns its own electrical infrastructure and has a district energy system. Onsite energy provides a substantial amount of electricity, steam, and chilled water for this campus, with CHP being the primary technology here. Uh, Having a resilient energy supply for the campus is a priority because it's home to many students, as well as hosting many critical research projects. So both campuses have a microgrid that, with a CHP system, can support critical facilities in operation. We have 17.5 megawatts of CHP that includes gas turbines and a steam turbine. And then on our Centennial campus, we also have a chilled water storage tank that holds 3.3 million gallons and a combined solar PV array and battery storage system that helps reduce peaks, as well as generating renewable energy for the campus. The CHP system alone reduces greenhouse gas emissions from the campus by over 50,000 metric tons of CO2 equivalents annually, which is about a 12% reduction of GHG from the baseline here. And these technologies here, just like the ones at BMW, are the ones that the on-site energy taps are, offering to work with you, industrial facilities, and other large energy users to identify and evaluate for your facilities. A third example is United Therapeutics. This site set a goal very early on in the process of developing a net zero facility, and they manufacture treprostinil. It's a therapeutic for pulmonary hypertension treatment. And they did a great job of achieving their goal through the use of on-site energy. One of the things that they wanted to do was to avoid the use of fossil fuels on site. So there's no natural gas, diesel, or propane generators on site. And they do need to have resilient energy because they have critical operations here with extensive cold storage facilities. And so to provide the energy for the site, meet their net zero goals, and provide resilient energy, they have a 434 kW AC PV array, a 1.54 megawatt battery storage system, and then a geothermal heating and cooling system that has 40 closed loop or vertical wells that go 500 feet deep. Through the use of all these technologies, they were able to reach net zero, and overall they use 30% lower energy use than the baseline facility, and were able to achieve a LEED certification at the gold level shortly after opening here. So great job here. You can see in the graphic on the upper right here, how the battery storage system is projected to perform, where it does store energy from the PV at times. It can dispatch that at times to help meet peak demands. And so you see up at the top the state of charge of the battery. It starts out charged, and day one goes down as it gets charged up. It goes back up, and so on. They maximize solar PV on the rooftop here. And this is a great example of how it's important to really look at on-site energy and set these priorities early on in the process. Not only do you get a really great integrated design, but it actually helps to keep costs of on-site energy lower than if you were to come and add it later on to the facility. So I'm happy to talk about any more of these, answer any questions about these sites here, as Art and I have been to the sites as know the folks that are involved in developing these sites. All right, so next I'm going to talk about portfolio and site screening for on-site energy. So the graphic here in the upper left shows a pathway to decarbonizing any type of building, industrial operation, campus, what have you. And it does that through 3 steps. First step is to avoid or use less energy, and energy efficiency is probably the prime strategy there. The second step here is to shift towards low carbon solutions. That can include electrification, but also includes on-site energy technologies, including the use of renewable energy, low carbon fuels, and feedstocks, as well as making sure that you have low global warming potential refrigerants and low carbon processes in your site. So on-site energy is a key solution in step 2 of this pathway towards decarbonization. The third step in the pathway is to sequester unabated emissions, and the technology that people are talking about for that that's emerging is carbon capture and storage technology. All of this is happening, all this process, this pathway is happening on site. And that's why we called our webinar Decarbonization Begins on Site. Often you'll hear about procuring green energy from your utility or RECs or offsets. Well, those are things that do have an impact, but we feel like the biggest impact you can have is on site. And that way you can control your costs, control your energy sources. And here's 2 examples of facilities that have done that. They're using their available resources. On the lower left, you have a ethanol refinery, Western Plains Energy in Kansas. This site has a 2.7 megawatt wind turbine. In the upper right, Sierra Nevada Brewing in Mills River, North Carolina. They have 600 kW of solar and 400 kW of micro turbines there on site that are fueled by biogas that are produced as a result of digestion of leftover grain from the brewing process. So 2 great examples of how they're using available resources to decarbonize on site and meet their sustainability goals. Lower right graphic here shows a process for evaluating on-site energy opportunities. And this is kind of the process that the on-site energy taps follow, and that many sites would follow. And they start with portfolio level analysis, looking at facilities across an organization's portfolio to prioritize those that have good on-site energy opportunities. The second is to do site-specific level technology screenings. And then from there, you would move to do advanced analysis or feasibility assessment for opportunities that look favorable to the organization. So here's a table that breaks down some of the factors that you should look at to determine whether you have a favorable on-site energy project development opportunity. There are regional factors, and that may have to do with things such as what are the solar or wind resources or other energy resources in the area. Or, for example, is there the third-party ownership allowed? That would be a way that an organization could work with a third party that would invest the capital. Maybe that third party would actually own and operate the system and provide your site with power and steam or steam, I should say. In fact, in Puerto Rico and other places in the United States, third-party ownership of CHP systems and other on-site energy systems is a common practice. There are state and utility factors that may incentivize or provide support for on-site energy. One of those could be a renewable portfolio standard, as well as net metering. These are important policies that help on-site energy to be used by facilities, as well as providing rules for them to interact with their utilities. And in the second webinar on August 8th, we'll go into depth into a lot of these state and utility factors. There's also facility organizational factors that has to do with things as to what your ownership is of a facility, what the plan is for the facility. Is it a long-term kind of operation, such as the BMW assembly plant, where it's been there for 20 years and will be there for a long time to come. Then there's also site-specific factors. To do things like solar PV on your roof, you need space or space on your site. There must also be, sometimes loads that are suitable for a on-site energy system. You want to have fairly constant loads, and then you want to pay attention to things like your thermal loads, as well as your electric loads, and identify those as potential on-site opportunities. This table here breaks down technology specific attributes that may indicate and help us really determine which technologies we should look at for a site. That includes what your electric rates are, what your fuel prices are, demand charges, what the available space is, the thermal load, some of the things that I talked about in the last slide. And a good way of, just it's a very simple way of being able to, check off some of these things and rank, these different technologies as based on what these site attributes are. So the more of, positive, you can have under these different technologies and criteria, the better it is probably going to be for you to look at, one of these specific technologies. And we will, work with you to look at, all these factors, both the technology specific factors and the site factors in what we call the portfolio analyses or site analyses. A tool that we use, that the on-site energy taps use for evaluating on-site energy, is the National Renewable Energy Laboratories REOPT tool. REOPT is a program that's actually available online, and it's able to optimize a range of on-site energy technologies based on data that you put into it, and come up with optimal cost solutions. And it does this by taking either hourly data that comes from the site or typical hourly load profiles for the site. We'll include a detailed model of the utility rate for the site, and model how each we'll start by looking at individual technologies and determine how they stack up, and look at those technologies 8,760 hours a year to come up with what the savings are. Then they can also look at portfolios of these technologies, combinations of these technologies, and all the on-site energy technologies that I talked about the program covering are REOP has capabilities to look at those technologies. So the first, and then that's in the first mode of this tool, the financial mode. It'll optimize these from a financial standpoint. There's a resilience mode, which can take and look at these an outage condition and optimize how these systems would work together. And they could include existing backup generators to show how you would sustain critical loads during grid outages with these technologies. Here I'm showing the modeling approach to a portfolio prioritization. This is not something that's this is something that's really great for companies that have a lot of sites. We're working with a company right now that has over 80 sites in the United States and uh, have done a portfolio prioritization for 27 of their sites. And we took detailed inputs, modeled it in Reopt, and came up with some results for them that included what the on-site energy potential is for the site, what the economics of each technology are for the site, and then what the emissions impact for those technologies are. And using that data and also, their own knowledge of the sites and also looking at the state and local policies and incentives, we're working with them to filter those 27 sites down to a smaller subset of sites that we can do site-specific screenings for. And I think I'm going to pass over to Art here. And much of what Art's going to talk about is going to apply to the site-specific screenings. So let me give it over to you, Art, and I'm going to give you the remote control here as well.
Okay. Thank you, Isaac. And welcome, everybody. Thank you again for attending. So this next part of the presentation is going to, as Isaac mentioned, going to focus a little bit on the benefits of on-site energy. And, if we were to do a poll on really what are the primary reasons that a facility may be looking at on-site energy, it really comes down to economics, emissions, and resilience. Okay. And different facilities have different priorities with regard to those three. There's not one does not fit all. It depends upon what your goals are. So we're going to kind of touch on each of these three in this section of the presentation. And hopefully, let's see. Yep. Wait a second. Yes. Okay. It advanced. Great. So agencies that establish policies and procedures for accounting of greenhouse gas emissions really look at two different factors. One would be, at your facility, are you doing an inventory of, say, your scope 1 and scope 2 emissions? Those are really attributional accounting procedures. You're looking at your site's attributes with regard to greenhouse gas emissions. And the way you would do that, if you were doing it for your scope 2 emissions, you would base your greenhouse gas emissions on your consumption with an average grid emission factor for greenhouse gases, right? However, if you were to deploy any kind of on-site energy generation technology, that has a consequence to the grid, right? You are now utilizing or generating energy that would otherwise be taken from the grid. And in some cases, you're actually putting energy back onto the grid. So that has an impact to the grid, to the ability of that grid to meet the overall regional load. And when you are assessing the benefits of your on-site energy project from a perspective of greenhouse gas emission reduction, you really would base that on what's referred to as a marginal grid emission factor. And we're going to talk about that a little bit more on this next slide. So imagine you work for a utility and you're in some dark room in a 40-story building, and your job is to dispatch utility assets. You have two major mandates. Number one, make sure you're able to provide the load that's being required on that particular day, and do so with the least cost assets. So if you look at it, we have two different scenarios here. So picture a day like today, a hot summer day. We started out in the morning. The demand on the grid is pretty low. And in that situation, you probably have mostly your base load plants that are operating, right? You have your nuclear plants. You have your combined cycle or coal plants, your base load large generating units. And then you have some other, maybe some wind, depending upon your location, because wind is available 24/7, depending upon the weather conditions, of course. Now, as the morning progresses, the load starts to increase. and you start to dispatch more and more assets to meet that load. But at the same time, you have more solar coming on the grid, assuming the weather's sunny and hot. So you're trying to balance the fact that you have renewable energy resources coming onto the grid. At the same time, you're trying to balance the fact that you're adding more of your utilities assets. So let's look around this time of day when you were at the peak time of the afternoon, when your load on a summer afternoon is probably peaking. There's two ways of looking at the emissions on right at this hour of the day, if you were accounting for those emissions. One would be what you could say are your average emissions. So if you look at that first plot there, that first graph, go vertical from top to bottom, it would be the average emissions from each of those assets, of course, prorated by their contribution to the total generation at this particular time. But in reality, if you were to deploy an on-site energy resource in the middle of the afternoon, the impact or the consequence to the electric grid is that you are impacting probably that last generating unit that's put online, because as the load is increasing, this person who's sitting in that room in the utility building somewhere is dispatching increasingly less efficient units. And in fact, some of these units near the top here might even be, say, oil-fired engines that are just being put on to meet an extreme load. Maybe not like today, but maybe on a day when it's 103 degrees like it was last week. So your project is going to impact that last asset that's put online, because if everybody else did what you're doing, you would minimize the need for that one marginal emission point right there. So that's why when you are accounting for your impact to your emissions, when you put on when you install an on-site energy source, you would look at marginal emissions. Okay. There. So when Isaac was discussing the analyses that we do, and he talked about the REOP model that is used, what we're looking at here is really a summary table of output from an analysis that we conduct for a particular. This is an example site. Okay, so for this site, we looked at 3 different technologies, and in reality, as Isaac said, we look at all technologies, right? We look at all technologies that are applicable to your site. It depends upon, your objectives for putting on, for adding on-site energy. It depends upon your site configuration. It depends upon your climate. There's a lot of factors that ultimately will whittle down the technologies that ultimately get evaluated. In this case, we looked at solar, we looked at wind, and we looked at combined heat and power. We also looked at a combination of PV and CHP and wind and CHP. And if we start with the business as usual case, which is basically you don't do anything. This is what things look like right now. So let's kind of look vertically down some of these columns here just to see the impacts of these different technologies. So if you just start with the business as usual case, you see basically how much consumption they're using a year, what their peak demand is, what their natural gas consumption is, and their thermal output from their boiler, which is probably about 80% of the thermal output, the natural gas. And what this basically saying here is the natural gas at this site is all attributed to that boiler. All right, let's look at just installing an on-site PV array. Okay, so based on the model that was performed, the model that was done, we estimate about 382 kilowatts system. Okay, and so what that will do, that will generate almost a half a megawatt hour a year, about 498,984 kilowatt hours per year, and about 480, in this case, about 482 megawatt hours serving the load. Of course, sometimes you generate more than you need, so you send some to the grid. Bottom line is, if we go down a bit, what you'll see is that though the site energy use doesn't change, you are reducing the purchased electricity by 30% just from installing this 382 kilowatt PV system. And that reduces demand a bit, about 11%. It doesn't touch your thermal load, right? Of course. So it doesn't change your natural gas consumption, but you still end up with a 418 metric ton per year reduction in carbon dioxide, 13%. We'll quickly go down the next column for wind, similar size, right? 318 kilowatts. Numbers look pretty similar. Reduces net energy purchased by 27%, right? Reduces the peak demand by the same. It just happens in this case to be the same reduction. And you end up with about 550 metric tons and 17% reduction. CHP, a little bit different because now you're combusting a fuel, natural gas in this case. It's actually a unit of similar size to the other two, right? But it's available all the time, right? And that's, the difference between, say, CHP and other on-site, some of the on-site technologies. CHP does have the higher annual capacity factor of 90% or higher. So the net purchased electricity savings is about 80% in this case. And it still reduces peak demand, in this case, about 31%. And now you do end up consuming a bit more gas, natural gas with a CHP system, but that natural gas you're consuming is addressing both your scope 1 and scope 2 emissions, right? Because you have a more efficient system, but you're also generating your thermal and your electric from that same fuel. So you are having you do still end up with about 750 metric tons per year of reduction, about 23%. And then those last two on the right are combinations thereof. And of course, they do have that cumulative impact of increasing CO2 emissions a little bit greater because, but what's interesting is what the model is really doing is it's figuring out for each hour what technology is contributing to that facility's need at that time when you're combining these impacts. So when you're combining these technologies, I mean. Okay. So we're going to have two slides that are similar to this. One here, and then in 2 slides from now, we're going to look at the economics a little bit more. This is more of the output from the energy perspective. So we talked about the fact that we use this REOPT model, which is a very sophisticated, very really cool model when you think about it, that you can model multiple technologies on an hourly basis with multiple fuels, and it's going to let you know for each technology what the impact is at your site. And the model is based on a Cambium grid modeling that assumes a certain rate that the grid is going to change over time. There's many things that affect what the grid's going to look like, say, in 25 years from now. It could be the mix, the energy mix, and how utilities generate electricity. It could be the energy mix. It could be the incentives that are out there that might affect what types of renewable energy sources are added to the utility grid. It could be there's a whole host of assumptions that could be made. What's going to affect the grid going out 25 years? And what the Cambium model really does is it can generate these 3 scenarios of different assumptions, sets of assumptions, and the impact of that is that is the trend of the reduction in the CO2 in the CO2 equivalent of the grid over the next 25 years. So what we do to remove a lot of that uncertainty is we use what's called, so I said this Cambium model projects out for 25 years, but what we're really doing is using the year 1 projection of Cambium. So we take away the uncertainty with regard to what's really going to happen to the grid over the next 25 years. So it uses a marginal emission rate. We talked about that previously, and it it uses existing data to project what's going to happen next year, starting next year, out for the next 25. And it's that first year that is used to determine the GHG reductions from the different technologies. Okay. So this is part 2, if you will, of the example we just were talking about. So we talked about how much energy, what the system sizes are. That's the same if you look on top there. This is the same example as 2 slides ago, okay? And what we're looking at here, though, are the costs, okay? And what we can see is if you go down again vertically, the purchase electricity cost, for example, business as usual is about $159,000. And the PV, just PV by itself would reduce that to about 125,000. And then it continued down. You have some exported power to the grid. And so and then we have the cost. What you'll see if you keep going down there, you'll see the net operating cost savings, about $28,000 with capital costs and O&M. The payback for the PV, that 382 kilowatt PV systems, about 8 years. For wind, again, the size is similar. The cost is a little bit greater for the wind for that 318 kilowatt system. But you're still exporting a little bit more power to the grid. And so the purchase electricity cost is $128,440. And some of that could be because the fact that it's a little bit higher than PV is the fact that you might be exporting power to the grid when your site doesn't need it. And therefore, you're not getting always the benefit of having wind at the most expensive times of the day. So, and you can look at that a little bit more detailed in the model output. So the wind turbine has a payback of about 11 years. And then again, with CHP, you're reducing your energy costs, or you're increasing the energy cost savings quite a bit, right? You're doubling it from wind to about 100,000. Your gas costs are a little bit higher because, again, like I said, you're spending about $45,000 more in this case, for natural gas. But that's offsetting a lot of the electricity. So you are actually getting a net payback, and and with the capital cost and the payback and the savings, it's a payback of about 12 years. And then, of course, the last two are the combinations thereof. They have a slightly higher payback, and that has to do with just the fact that sometimes pairing technologies does not always result in the cost savings that you would like, and it has to do with when those systems are available, because again, we're modeling this on an hourly basis. So that's something you could look into the model a little bit more to get a better understanding of. But the bottom line is, in this case, you're still getting pretty good payback on all technologies. And again, the other thing you have to keep in mind is when a facility looks at, remember, we're talking just economics here. Sometimes a facility's priorities are not just the economics, right? They're the CO2 reductions. And, when I went, I'm not going to go back 2 slides, but if you remember, different technologies have different CO2 reduction potential. So it's a complex decision-making process. And our job really as the TAPS is to provide you with as much information as you have to make that informed decision, because you know what's best for your facility. You know what your facilities and companies' goals are. This provides you with, we hope, that information to help you make that decision. It's not based on just one factor, because there's also resilience. And I'm going to get to resilience in a minute. Part of resilience is to have the right technologies. Now, all technologies provide an amount of resilience, right? But, combined heat and power is a technology that's been around forever. It's a technology that provides that base load component to a microgrid, say, that has multiple technologies, both a CHP based microgrid, and you could add solar or PV, solar, maybe battery storage, which I'm going to show you a slide of in a minute, and even wind if it makes sense. But what's interesting about CHP is that high annual load capacity factor, okay? And the fact that you are using the same fuel to generate both the thermal and the electric energy for your site. So if you were to install a natural gas-fired CHP at your site, even though it's natural gas and your scope 1 emissions could go up, most likely will go up a bit, your total scope 1 and scope 2 emissions will likely decrease. And that's because of the added efficiency of a CHP system over a traditional system where you have a boiler on site with grid power coming in. That's about 45 to 50% efficient composite. The composite efficiency is about 45 to 50%. If you have a CHP system where you're from that same fuel generating both thermal and electric, this says 70 here. We've seen systems that are actually over 80, but 70% is a good conservative number to base calculations on. So, and again, basing and again, looking at these reductions with marginal emissions is what really is important to do. And what's interesting is marginal emissions. I was looking at 2022, for example, and in 2022, in the balancing authority in eastern half of North Carolina, which is called CPLE, it's the old CPL name, eastern part of the state, the annual average CO2 emission factor is about 522.8 pounds per megawatt hour. The marginal emission factor is about 1393.8 pounds per megawatt hour. So it's looking at the fact that these systems will reduce the need for those least efficient units. That's where you get a lot of these savings. And as with CO2, with CHP, the other element of CHP that is important to recognize is, while this example is one using natural gas, CHP has the potential to be fueled by a wide variety of fuels. And there's a lot of focus on renewable natural gas becoming more and more available in the future. And this on the right side here, as you can see, the projections are an exponential increase in the availability of renewable natural gas. Gas utilities are even looking into this. And that would be one way that CHP can continue to support a reduction in your CO2 emissions. And if you look, it's from a wide variety of feedstocks. And the thing is, these feedstocks are already here. I know there's a lot of talk about hydrogen, and hydrogen will become an important fuel in the future. It definitely will be. But these feedstocks, they're available right now. So that's why if we harness the ability of these feedstocks to be used to produce renewable natural gas, that potential is huge. And that's what this graph is showing here. And the other thing is, it could be used for a wide range of applications: industrial, commercial, institutional, college campuses. And to further accentuate this, is what this graph is showing is there is the relative reductions in the life cycle carbon emissions of these different fuels. So, for example, if you look on the left side of this slide, you'll see where diesel and natural gas are. Again, this is a life cycle emissions. Okay, so it's not just the combustion, but it's also it incorporates the production of these fuels also. So go down the list there, you see that, RNG from landfill gas, from landfills and wastewater approach zero. But once you start involving food waste and other types of organic waste from our waste streams, we start going negative. And the most potential is really from animal waste. We've seen projects with where they've done life cycle analyses of renewable natural gas from hog farms, from hog waste lagoons, and these numbers are like 500 minus 4 or 500 grams of CO2 per megajoule of output. That's the term EPA uses, grams of CO2 equivalents per megajoule of energy produced. So there's a lot of potential both from these technologies like solar and wind and geothermal heat pumps, but also from traditional combustion units also. And what the TAPs do is we look at all these different technologies and fuels to help you make the best decision for your site. And we have one more slide here. Can't forget resilience. I mean, we've talked to facilities, both Isaac and I have had conversations with facilities where they'll tell us that a half-hour power outage can cost them 4 to 6 hours of production and hundreds of thousands of dollars because people, you lose a lot of the fee, a lot of the whatever it is you're making. Sometimes you have to literally start over. You have to reboot the whole plant. It could make people stand around, or maybe they even have to go home. So you lose a lot. So there's an energy resilience component that has always been an important part of the on-site energy picture. And if you look at this slide here, near the bottom, what you'll see is a microgrid with CHP and PV with battery storage. So let's start from the early part of the day. The hatched areas from top right to bottom left are your CHP. From the top left to the bottom right is your PV. And then you have different parts of the day where they're interacting differently. So for example, during the low part of the day, or during the low load part of the day, you're really storing up the energy at that point, right? So the CHP system is going to be operating. That's your base load system. But when that excess power is not needed, you can actually charge up your battery, right? And then during the day, as the load ramps up, but the solar resource does not, because it's still early in the day, you can utilize and start discharging that battery to help meet the load above the line there, the dotted line, okay? So that's that blue area there. That's your battery kicking in and helping to augment the power from the CHP system. As the day progresses, the PV ramps up, and that really helps meet the rest of the load of the facility. And you can actually start during that period also charging your battery. And then during the latter part of the day, you start discharging the battery as the solar starts to decrease, the solar output starts to decrease, but the solar is decreasing faster than the demand at your site. So what this slide is really showing is how CHP, solar, and storage interact together to help meet a facility's daily base and peak energy loads. And I'm going to pass it over to Isaac, who's going to talk about how you can engage and work with the on-site energy TAPs. Thank you.
Thank you, Art. Great job there. So in the little bit of time left, I'm going to talk to you about how to work with your on-site energy TAP. Like I said, we are the Southeast Regional TAP team here. But depending on where you are, you can work with any of the other TAPs, and we can help connect them with you if needed. First step is to just contact us and have a discussion about what your goals are. We want to understand your operations, what you manufacture, and what your energy use is, and all that. We'll collect some site data from you. We like to look at electric bills or and fuel cost history. We'll want to understand your utility rates. And then we'll want to also understand what are the loads that you see. Is your electric load consistent? Is it tied to certain processes? Same for your thermal loads. What kind of thermal energy do you need? When do you need it? What type of quality is it? Is it hot water, steam, etc.? We'll take all that data, and depending on, if you have a lot of sites, we could do a portfolio analysis, or if it's a few sites or a single site, we can do a site-specific analysis. And we'll use the REOP tool and other tools as necessary to conduct an analysis and come up with basically the same kind of uh, uh, data, information, results that Art shared with you just now. And like I said before, we'll help you through the initial step. We can do advanced analysis to support the installations. And even in the process of evaluating and procuring and constructing your site, there's things that we can do to help um, to make sure that your project is a success. Um, Again, we provide example, here's some example results that show you the different types of technologies that we can look at for your site. Some of you may have been hearing about technologies such as industrial heat pumps or fuel cells. Those are all things that we can look at for you, but the basic things that we'll look at primarily are solar PV, combined heat and power, battery storage, and wind energy. And then we'll add on to that. We've looked at geothermal heat pump for a few sites already. So now here's a great opportunity to share with you. Under the bipartisan infrastructure law, Congress approved IAC implementation grants, and $400 million of funding was made available overall that is intended to provide these implementation grants for facilities that have received a recommendation from an industrial assessment center, DOE combined heat and power technical assistance partnership, or an on-site energy technical assistance partnership. And these funds are available on a rolling basis. There's an application that is administered, the process, the program is administered by Energy Works, and they have an application online for that. And the analyses that we would do would help you to complete that application. There are some eligibility requirements for the grant. The company must be a domestic manufacturing company. It has to have annual gross sales of less than $100 million per $100 million. The plant where the system would be at, there should be fewer than 500 employees, and you have to have an annual energy spend from somewhere between $100,000 to $3.5 million at the site. Like I said, these funds are available on a rolling basis, and a single company can apply for this grant once per quarter. So it's not a single thing, not a single time that you can get it for a single site. You can actually apply for this once per quarter. There's a lot more details about this grant. And if you get in contact with us, we'd be happy to share those details with you and discuss how it might apply to an on-site energy for your facility. It's a pretty powerful incentive. Let's say you had a project that was going to cost $700,000. You can actually get this $300,000 grant that would cover almost half the cost of it, and it really helps to improve your payback. I should also caveat that there is a cost share requirement of 50% for this grant. So you have to spend as much as you receive under the grant program. With that, I'll just summarize, and thank you for your participation here in this webinar. So the on-site energy program, it's this regional model, and we're here to help manufacturers and other large energy users to transition to clean energy. Um, we'll help you to evaluate a range of clean energy technologies to figure out the ones that are appropriate to your site and how they can be optimized to reduce your costs, reduce emissions, help you meet net zero, as well as to um, provide your site with resilient energy. In our program, we have on our staff folks in experience in not just project development, but also in the different policies, incentives, and programs that are applicable to your specific situation.
All right, thank you, both Isaac and Art. You've provided us with very detailed information about on-site energy, its benefits, and how people can engage with the TAP program. So I'd like to now open it up for a Q&A session. We have about a little less than 15 minutes left before we end. And go ahead and put your questions in the Q&A section of the chat. I see some coming in right now, and I'll go ahead and ask a couple to start off. One of them is, do you visit sites for on-site energy technical assistance?
Well, I'm not muted, so I'll take that question, Anna. Initially, the work that we do doesn't require a site visit. We can do a lot of the work virtually. Of course, if a site's located nearby, we wouldn't mind making a trip out to see you. But then during, an advanced analysis, there may be a need for us to come see the site. It's important to look at existing conditions out there to make sure that equipment, would fit where you might want to put it, or even strategize how to install it. So there are definitely, some reasons to visit the site later on in the process, and we'd be happy to do that and have the resources to do so.
Thank you, Isaac. Another question is, what's the timeline from start to finish from a company contacting the TAPs to being able to get a completed analysis? What's the timeline for that?
Well, the timeline really depends on, typically it's going to be, I'd say 30 days from when we first meet and discuss on-site energy for your facility till you can get a report from us. It may take less time than that. And it does depend on, making sure that we have sufficient information and data on how the site uses energy, what the energy costs are, et cetera, to be able to do an accurate analysis. Because we really do want to do, we try to do a good job of, providing results that are, very supported by, a lot of good data and assumptions.
Thank you, Isaac. And I did get a question that says, where are the questions coming from? We can't see them. We are only, as co-host, we can see your questions. And then once we have answered them, then they should show up answered. So from that, I can say we've answered that question live, and now you can see it. So thank you for that question. Another question was, what's your process for connecting end users to installation companies when they decide they want to move forward after an analysis? That's a good question.
Who do you want to answer that, Anna?
Art, do you have a?
Yeah, well, so we while we don't advocate for any particular vendor, we certainly can help you identify the the kind of the range of vendors that are out there, the services they provide, and also as part of our technical assistance, we are available to provide kind of a third party, non-biased review of specifications and proposals that you get from different vendors. So we apply the expertise we have on these different technologies, look at the information that you might be considering going with a particular vendor, and we can help you feel comfortable that that information is appropriate for that site.
So I want to add to that too, like Art said, we can't advocate. We want to remain unbiased as representatives of DOE. And one of the resources that is available to you through the DOE on-site energy program is the CHPE catalog. And I think I put that into the answer there. That is a resource where DOE has worked with manufacturers and providers of combined heat and power systems. And through that marketplace, they've been vetted, and you can actually go in there and see information about the different technologies that they offer and request quotes, from a number of vendors. Another thing we do too is, we're always working to, host and partner with folks around the region on events and engagements. And, that's, I think, a great way to, network people together, and a lot of vendors and developers will be present at these events.
Thanks, both Isaac and Art. Another question that I can answer is there a fee for your service, or is it covered under a federal program? So because we are funded under the DOE On-Site Energy Technical Assistance Partnership, this is the program that funds us to do this analysis for you, free of cost. So yes, it is free to you for us to do this analysis for you. So good question. Next question we got was, does using the re-op tool have any cost, or does it imply any commitment from the company that uses it?
Yeah, this is a question, we've seen before. So first of all, re-opt does not have a cost. There is no cost to run it. Plus, as Anna just said, if we were to run the program for you, run the model for you, of course, our services are at no cost to you. But it's also important to recognize that, and this was stated a couple times in the webinar today, our job is to provide you with information for you to make the decision that's best for you. It does not imply any obligation on your part to take the information that we provide and move forward with the project. It's really for you to have as a way of planning your future strategy for energy and decarbonization.
Thank you, Art. All right, another question we've gotten in the chat is more of a scenario. So I'll kind of read this out and hopefully we can follow it. It says, let's say that a wastewater facility feeds biogas to a P3 RNG, which is renewable natural gas facility. And eventually this P3 facility feeds the RNG to the pipeline. Considering that the facility would buy back the RNG from the pipeline, how would the wastewater take into account the offset of the feed biogas if it is buying back the RNG from the pipeline, which has a mix of sources that make up the natural gas? Considering if the wastewater facility buys back the RNG, would this be considered a renewable way of burning natural gas?
Wow.
So it's an interesting scenario, and there's probably a lot of nuances to it. And I guess I'm surmising that P3 stands for public-private partnership. And that's, I think public-private partnerships are great, where, private organizations can invest capital to help support public entities. Art, what do you think about that scenario there? I guess it depends on, really the mix. You'd kind of weight each kind of the constituents of the biogas.
Yeah, the consumer of the biogas is who would take, if it's an accounting question, the consumer of that biogas is who would take that would have to look at the carbon intensity of it. And I guess, so if the wastewater facility buys back the RNG, would this be considered a renewable way of burning gas? I would say yes, because you are burning renewable natural gas produced from wastewater sludge, I believe, is what it's referring to. And so the bottom line is there is renewable natural gas being put into a pipeline. Ultimately, where it gets used or who uses that renewable natural gas, that is considered, that user is using that renewable fuel. I don't know, is that answering whoever, I don't know who posed this very interesting question.
Yeah.
The pipeline is not all biogas. That's right, but it's an accounting, thing. You know, that's a great point. So when you utilize RNG from a pipeline, it becomes almost like a molecule accounting activity where you are, the utility knows how much biogas has been put on that into their pipeline, and how much is being sold. And so there's at some point the that renewable natural gas is no longer present, I guess, from an accounting point of view. But it is kind of complicated.
So
But I believe that there's a certain amount of renewable natural gas being put into the pipeline. You're then buying the attributes of that renewable natural gas. You can take credit for that.
All right, thank you both for addressing that question. We have time for maybe one more. This one is just one of my questions. Can you help a site apply for an implementation grant?
Yes.
So yes, absolutely. We've worked with sites to apply for this implementation grant, and they've been accepted for the program. Like I said, the analysis that we did, the report supports the application. It's part of the eligibility that you do receive an assessment from an IAC, an on-site energy tap, or there's also qualified third-party assessors that have applied to DOE to be approved. But working with on-site energy tap is one way to get the assessment that you need to be able to qualify for the grant. And then, we can't actually fill out the application for you, but we can, provide, the report provides all the information you need, and we can actually sit down with you and, help with any questions that you have about the application, about it.
Great, thank you, Isaac. And I think that will wrap up our Q&A session, as we just have 1 minute left. And Isaac, if you want to advance to the next slide.
Sure.
Thank you. All right, I just want to thank everybody again for attending our session. We're really excited that you've come and for your attention. Please join us for our next 2 webinars in this series, the next one being on August 8th, which will cover those policies, programs, and funding in order to, fund this project and help implement it for you. And the last thing being on September 5th for deployment best practices, talking about example projects and what lessons they learned and best practices that they found. And if you weren't able to sign up for those last 2, please use that QR code on the screen to sign up again, and it will, send you that Zoom invite again. So again, thanks everyone for attending, and we hope to see you next month. Thank you.
Thanks. Great job organizing the webinar, Anna, and also for setting up the continuing education credits for that. So everyone contact Anna if you're interested in those.
All right. Thank you guys so much. Have a great afternoon.
Thank you.